Hello, welcome to today's drive-through. Today I'll be solving number 3 of the problem-solving set, which asks, using vectors, prove that the line segments joining the midpoints at the sides of a parallelogram form another parallelogram. And to do this, I've drawn the parallelogram for you. I've assigned the vectors v and u to identify the sides, and it's 2v and 2u just to make things easier when we break it up. First, I'll show you how these components broken down of the ABCD parallelogram prove that it's a parallelogram. So I'll show you that these sides are perpendicular using these components of these vectors that I labeled. And then I'll use these same components to show how the point sets E, F, G, H, the midpoints, are also a parallelogram. So first, I'm going to identify the points of A, B, C, and D. For D, I'm assuming that U is just a horizontal vector. It could be, it doesn't have to be, but for simplicity's sake, I'm going to assume that it is completely horizontal. So first A, we'll make that point 0, 0. B, we'll make B equal to 2A and 2B. It will make C equal to 2A plus C, comma, 2B. And D, C is equal to, C is 2A plus C, 2B. And D is 2C, 0. And so what this really means is 2A is this distance. So we'll just draw this in right here. No, actually, it's this distance. This is 2A. This is 2C. And this height is 2B. So A is 0, 0. B, 2A for the X, and then 2B for the Y. C is 2A plus 2C for the X, and then for the Y it's also 2B. Then D is 2C, 0. And again, this could be a completely different variable, but for simplicity's sake, we're assuming it's 0 for now. So what we're going to do, we're going to get our vectors set up. So we're going to have AB, subtract the 2, and that equals 2A, comma, 2B. And now the alternative would be DC. So DC equals, let's see, AB, DC. So I subtracted B minus A, so I'll subtract D minus C. So 2C minus 2A plus 2C, comma, nope, that's the wrong way around, excuse me, 2C, 2A plus C, minus 2C, comma, 2B. Simplify that, we get 2A plus 2C minus 2C, comma, 2B, blah, blah, blah. We end up getting the same thing as AB. And that's basically the trend. So if we completed this pattern for additionally AD and BC, we'd get that the vector components are the same. Traditionally, if they're parallel, if you can multiply them by any constant, then they're parallel. Obviously, if you multiply these by 1, they're going to equal each other, they're going to be parallel. So by using this principle, we'll use these same components to show how these two are parallel and these two are parallel. So let's go on to define 4 more points. We'll start with E. So E, using this system, is half of that, so A for the X coordinate, and for the Y coordinate it's just B. F is 2A plus 1C, so 2A plus C for the X, and for the Y it's just 2B. G, this point right here, is 2C, this length of U, 2C plus 1a. So we'll just keep that in order, a plus 2c. For the y value, it's just 1b. And h. H is right here. So that would just be c, comma, 0. So let's set up some more vectors. EF, we know is 2a plus c minus a, comma, 2b minus b, which simplifies to a plus c, comma, b. The opposite segment would be hg, so that would be equals gh. So it would be a plus 2c minus c, comma, b minus 0, which simplifies to a plus c, comma, b. So see how these two are also the same. They're the same components. Multiplied by a constant of 1, you get that these two vectors are parallel. And we can continue, and we will continue on to these next two, just to drive home that it is in fact a parallelogram. So we have EH, and then its counterpart is FG. We'll start with EH. EH is C minus A for the X, and 0 minus B for the Y. Simplified, we get C minus A, negative B. And then alternatively, FG equals A plus 2C minus 2A plus C, comma, B minus 2B. Simplified, we get that cancels, that cancels, that cancels, that cancels. So we have C minus A, comma, negative B. And you see how, once again, these two vectors are parallel. And if you have a set of 4 points and they're parallel on both sides, you get a parallelogram. Boom!